Today I'm a speedrun teaching all of these derivatives. I know technically this is not all of the derivatives. This is like clickbait, but the first one is the limit definition, right? Uh, I'm gonna quickly write the actual stuff. It's like the limit as h approaches zero of f of x plus h minus f of x divided by h. This looks complicated, but like let me draw a graph, right? Hold on, this thing like a curve. And what is a derivative? It's just the instantaneous rate of change at a certain point. That's a cool way of saying it's a slope at a certain point, like here, right? And let's say I'm gonna name this point x, right? And I'm gonna name a certain point, let's say here, x plus h. And if these points get closer together, like let's say this comes here or here or here, the slope of it becomes closer and closer to the slope of tangents, right? Holy, why is it cluttered? Yeah. So I'm gonna just I want the limit. Okay, wait. I gotta calm down. What is this y coordinate? It's just f of x plus h, right? What is this y coordinate? It's just f of x, right? Okay, what is the slope of these two points? It's just gonna be y2 minus y1 divided by x2 minus x1, right? What's y2? That's just f of x plus h. What's y1? F of x. Uh, what's x2? That's just x plus h. What is x1? That's just minus x, right? And you can see these cancel out, so it's just going to be h. And we said we want h to be closer and closer to x, so we're just going to take the limit as h approaches 0. That's kind of it. The reason you can't just say h is 0 is because like you're dividing by 0. That's kind of sussy, I guess, bro. Like once you learn other techniques, like let's say power rule, product rule, you stop using the limit definition really, because like nobody use. What's going outside, bro? Hold on. All right. Anyways, I don't know. I was getting bombed or something. I don't know. But the limit definition is like the most underrated one and overheated, right? Because with the limit definition, you can prove the power rule, the product rule, the quotient rule, and the chain rule, right? And with those, you can pretty much do everything, right? And the limit is like the best one. Like let's say I forgot. Wait, how to prove the product power rule? Um, yeah, let's say you have a function x to the n, right? So the limit definition would say it's just a limit as h. Like you want to find the derivative of this. My bad. This is just limit as h approaches 0 of x plus h of n minus x to the n divided by h, right? Uh, yeah, yeah, this is easy. Okay. So this is h at 0, and let's say we'll use the binomial expansion, right? So this is just going to be nc0 of x to the n, which is, wait, okay, yeah, which is just x to the n, right? Because nc0 is just 1, so it's just x to the n, plus nc1 of, and nc1 is just equal to n, right? Because this is just n factorial divided by n minus 1 factorial times 1 factorial. 1 factorial is just 1, and n factorial is just n times n minus 1 factorial. So this cancels out, so this is just equal to n, right? Side tangent, but anyways, so this is just n times x to the n minus 1 plus, oh wait, times h. Yeah, I forgot times h. Plus, nc2, my bad. nc2 x to the n minus 2 times h squared, yada yada yada. And then there's a minus xn here, so yeah, divided by h, so these cancel out, so I get the limit as h approaches 0 of nx minus 1 h plus nc2 yada yada yada. You can factor out an h from this, so this is divided by h, yeah. So this is just limit as h approaches 0 of h nx with n times x to minus 1 plus nc2 of h, wait, of x minus n. Holy, I'm getting cluttered, but yada yada, right? Divided by h, you can cut these out. So this is just the limit as h approaches 0 of nx minus 1 plus nc2 x n minus 2 times h. But you see all of these have h in them, and you can plug in 0 and this will get 0. So the final answer is just n times x to the n minus 1. This is what the side tangent. I didn't mean this, my bad. But you can see, like, you can even prove the product rule, the quotient rule. All of these rules can be proven by the limit definition. So yeah. Wait, what was I saying? Power rule. Okay, yeah. Power rule, right? Let's say you have x to the n. If you want to differentiate this, bring the power down. So just n times x. Subtract 1, n minus 1. That's it. Let's say you have x to the 6, 7. Ooh, 6, 7. Bring the power down, 67. Subtract 1. So it's going to be 66. You can do this for pretty much everything, right? I was going to write sine. You can't do it for sine. Yet. You could, technically, but like I'll say that later, right? Yeah, that's it. I did some questions. Oh yeah, the derivative of a constant is 0. So just remember that. Okay, the first question is x squared. I said you bring the power down, so 2. Subtract 1 from the power, so 2 minus 1 is 1. X to the 1, which is just x, right? So the derivative of x squared is 2. Derivative of 2 pi, with respect to x at least, is just 0, because pi is a constant and 2 is a constant, so it's just 0. This seems hard, right? But you can see there is no x, so you're not, this is just a constant at the end of the day, right? So the derivative of this is 0. Okay, what happens if you have a constant here? You can just pretend it's like technically not there. Like, no, not like that. Like, look, bring the power down. 3 times, you just bring the power down, right? So this is 4 times 3, and then subtract 1, so this is just x to the square. I don't know what I'm saying, I'm high. This is just 12x squared, right? You just bring the power down, do the same thing. Just multiply in the end, right? Same thing here, right? Negative 5, bring it down. So negative 5 times 3, that's just negative 15. Subtracts 1 from the power. So negative 5 minus 1 is not 4, it's negative 6. So be careful, I guess. Okay, this question is hard, right? Technically, right? 3 over 6, 7 to the x to the 5, right? This seems hard, but remember, like 1 over x to the 5, this is just the same as x to the negative 5, right? So you can rewrite this as 3 over 67 times x to the negative 5. And then you just use the normal power rule, right? So you bring this down, so negative 5 times times 3 over 67, that's just negative 15 over 67. You subtract 1 from the power, so it's just going to be x to the negative 6. And if you want to rewrite this in a cooler way, x to the negative 60, x to the negative 60, wait, it was 6? Yeah. So x to the negative 6 is just 1 over x to the 6. So I'm going to just write this as 1 over x to the 6, and you just multiply this. So it's just that in the end, right? Whenever you see a square root or like a cube root, right, you want to change it to a power, right? So root of x is just x to the half. Yeah, you feel me? So if you differentiate this, you're gonna bring the power down. So half times x, and then you subtract 1 from this. What's half minus 1? That's just negative half. Yeah, negative half. And that's it. You could make this cooler, right? So x to the negative half is just 1 over 2 times x to the half. And x to the half is just square root of 2. So that's just 1 over 2 root x, right? Cool way. 16. Man, who is making these questions? My bad, that's me. But if you want to differentiate this, we're gonna bring the power down, right? So 1/3 times 69, I think that's 23, right? Yeah, that's 20, that's just, wait, well, my bad. That's just 23 times x, and you subtract 1, 1/3 minus 1, that's just negative 2/3. So yeah, that's just the derivative, I guess. Okay, next thing is product rule, where, yeah, fine, product rule. So the product rule is like if you have two functions, u, v, like define, you're gonna differentiate the first one, u, and then just multiply, and then you're gonna differentiate the second one, you add, my bad, then differentiate this, and then just multiply. You just need some practice on this. I'm not gonna prove it using the limit. Or maybe should I? Nah. Wait, how long is the video? Yeah, we don't have time. I guess, yeah, we don't have time. So yeah, just bring the derivative of the first one. So that's just 2x multiplied by this. So it's just gonna be 3x plus 1. And then derivative of the second plus, my bad. Derivative of the second one, that's just 3. Because derivative of this is just 3, right? Because 1 is a constant and derivative of 3x is just 3. The reason for 3x is equal to 3 because you can treat this as 3x to the 1. So bring the 1 down, it's just going to be times 3. Subtract 1 is just x to the 0. X to the 0 is 1. So yeah, I guess. But yeah, you do this and then just multiply to this. So x squared. You could simplify this, but I'm lazy. Same thing here, right? Bring derivative of this is just 3 because like 3x plus 2. This goes. Yeah, we said that before, I guess. And then you just multiply by this. Plus derivative of this. Okay, what's the derivative of 2x squared minus x? Bring the power down, that's just 4x. Derivative of minus x is just minus 1. So this is just 4x minus 1. Wait. Put a bracket because you gotta multiply the whole thing here, right? So yeah, that's it, I guess. Okay, this one seems tough. This is just x plus 1 times x plus 2 whole squared. Since I didn't teach the chain rule yet, I'm gonna just pretend like I don't know the chain rules, right? So you could technically expand these out, right? And then differentiate. Yeah, sure. But I'm just teaching this because like further on it's gonna be harder to expand, right? But anyways, let's do this, right? Since I don't know x squared, let me just expand this one, right? X plus 2 whole squared. So x plus 2 whole squared, that just this x squared plus 2 I'm drunk, bro. X plus 4x plus 4, right? So I'm gonna just do this. And now I can use the product rule because it's just two products, right? So I'm gonna differentiate this, which is 1 times all of that. So that's this. Times I'm gonna differentiate this, which is like here, right? Let's say this is gonna be 2x and this is gonna be plus 4. So that's just plus, wait, 2x plus 4 times x plus 1. And then you simplify. And yeah, I guess. Next thing is the quotient rule. A good thing about the quotient rule is you don't even need to use it. Like, should I prove it? Yeah, because it's pretty quick to prove, but like, it's been 10 minutes already and I have like 17 years left, so fuck it, I'm not gonna prove. But basically, right, you don't even need to use it. Because x plus 1, and you can write 1 over 2x plus 3 as 2x plus 3 whole to the negative 1, right? So you can just do this. 2x plus 3 whole to the negative 1. And then you can use the product rule and the chain rule. But that's kind of cheating, bro. Like, it takes longer and it's not even quicker. So yeah, the better way is just like the quotient rule, right? If you have a function u v, take the derivative of the first one, right? That's just u prime, and then multiply by this. Minus, take the derivative of the second one, v prime, I guess, times u, and then divide it by v squared. That's it, kind of. Yeah, sure. It's pretty useful in most things. Like for this one, I'm gonna take the derivative of the first one, which is 1. Now I'm gonna multiply by v, so 2x plus 3, minus the derivative of v, which is just 2 times the first one, and divided by v squared, which is just 2x plus, what the, oh, hold on, whoopsie, which is just 2x plus 3 whole squared, right? That's it. That's the first one. The second one, don't be fooled. This is not a quotient. This is not a quotient rule. The reason is whenever you see one, like let's say there's one, what's it called? One term in the bottom, in the denominator. You don't use the quotient rule. Just divide it into separate ones. Like if this was x plus 9, then sure, use the quotient rule. But this is just normal x, so you can actually split this up, right? So instead of this, I'm gonna just write it as 18x cubed divided by x plus 67x, I guess, bro. 67x squared divided by x plus, what's happening, bro? Plus 9 over x, right? Simplify this, that's just 18x squared plus 67x plus 9 over x. Yeah, look, you can write 9 over x as just 9 to the x negative 1, because this is just, well, 1 over x, right? So you can write it as 9x minus 1. The reason we do that is so we can use the product rule, the power rule, right? So let's use the power rule. 2 times 18, that's just 36. Subtract 1, that's just going to be x. 67, I guess, bro. 67x is just 67, right? The derivative, This one, you bring the power down. So negative 1 times 9, that's just negative 9. Subtract 1 from the power, that's just going to be, it's not 0, right? It's just negative 1 minus 1, which is just negative 2. And you can write x to the negative 2 as, well, 1 over x squared. And just multiply that by negative 9, so it's just negative 9 over x squared. But I don't need to simplify because I'm sigma, I guess, bro. For this one, sure. We're gonna differentiate u, so that's just, the top function. So the differential of 2x squared plus 3x, that's just gonna be 4x plus 3. So that's just 4x plus 3 times the bottom one, right? X plus 9 minus the differential of the bottom one, which is 1, right? Because the differential of x plus 9, that's just 1. So minus 1 times the top one, which is 2x squared plus 3x, divided by the bottom one whole squared, right? And that's it. I'm telling you to simplify this, but I got no time, I guess. Alright, trig ones. Trigonometry is my favorite one, so let me lock in, I guess. So let's say you want to find the derivative of sine x, right? Fuck. How do you? Okay, fine. Let me go back. If you want to find a differential of sine x, you gotta use the limit definition. Like if you don't know anything, just use the limit definition, right? So let's say limit, sine x, right? F of x is equal to sine x. Okay, so f of x plus h is gonna be sine of x plus h. Simple, right? So let's put it here. Limit as h approaches 0 of sine x plus h, because that's just f of x plus h, minus sine x divided by h, right? What do you do now? Yeah, you expand this, right? If you have sine of a plus b, a plus b, that's just sine a cos b plus sine b cos a, right? Do the same thing here, right? So this is just the limit as h approaches 0 of sine x times cos h. This is not cosh, because I know the further you go in maths, there's something called hyperbolic trig. This is not cosh, this is just cos of h. Hold on, let me just cos of h minus plus sine of h cos x, right? Minus sine x in the end because of this, right? Don't forget this. Divided by h, right? I guess. What do you do now? I forgot. No, I'm joking. Limit as h approaches 0. So from this and this, I'm gonna factor out the sine x. Okay. So this becomes. What's happening outside, bro? Give me a second. Fine. Alright. Anyways, where was I? Yeah. You take out sine x from both of these, so you get cos of h, or find cos h minus 1, because you just took it out 1 divided by h plus this thing, right? Sin h plus cos h plus cos x, right? So you can actually split the limit. Hold on. Wait, I need more pages, I guess. You can split the limit. So this is just limit as h approaches 0. Sin x times cos of h minus 1 divided by cos, this one, plus sine the limit, as h approaches 0. Bruh, it's still outside, but this is rage bait. Anyways, if there's background noises, that's just because there's kids crying outside. I don't know, bro. Who's raising these kids? Anyways, this is just the limit as h approaches 0, this thing, right? So sin h cos x divided by h. So since sin x is not even related with h in this one, right? You can bring it outside the limit. This is the limit as h approaches 0 of cos of h minus 1 divided by h plus limit as same thing with here. Cos x is not even related with x, with h, so it's like a constant. So you can bring it out the limit, sin h over h, right? And you gotta know your limits. This is just 0, right? So this is just sin x times 0, wait, times 0, and this is just 1, so this is just cos x. So you get the derivative of sin x is cos x, right? Because this is just 0, this cancels out, this is cos x. Side tangent again, my bad. So this is just cos x, and for cos x, yeah, I'm not doing the whole limit thing again. How do I do this quickly? I have a plan. Hopefully it works. You can write cos x as this, right? Because this is the same thing as cosine of x, right? Like, yeah, you feel me? This is like the complementary. Anyways, this is just cos x. So if you differentiate this, this is just gonna be cos of pi by 2 plus x, right? Yeah. And cos of pi by 2 by x plus x, that's just negative sine x, I think. Hold on. Let me think. Yeah, this is just negative sine x, yeah. So yeah, I'm right. You could use this method to remember, I guess. Okay, how do you find the derivative of tan x, right? You could use the limit definition, but that's gay as I'm not swearing anymore. I'm a good boy now. Cause you can write tan x as this, right? And you could actually use the quotient rule on this, right? The derivative of the first one, which is just cosine of x, times the bottom one, which is just cosine of x, minus the derivative of the second one, which is just negative cosine of x, negative sine x, times the top one, which is just sine x, divided by the bottom one squared, which is just cosine squared x, right? Yeah, bro, I guess. So this is just cosine squared x, right? And this is just the cancels. I mean the negative cancel out. So this is just plus sine squared x divided by cosine squared x. And if you know trig, this is just equal to 1. This is just 1 over cosine squared x, which is secant squared x, which is right? You could do the same thing for secant. Like, let's say secant is 1 over cosine of x, right? So we're gonna use the quotient rule again, right? The derivative of 1 is 0, so it's gonna be 0 times cosine of x, which is just 0, I know, but like, for you to understand, right? That minus the derivative of the bottom, which is just negative sine x, right? Times 1, because the top one, yeah, my bad. Divided by cosine squared x, I think, right? Because that's the bottom one, right? So this is just, the zeros cancel out, right? Don't remember this. So this is just sine x divided by cosine squared x, which you can write it as sine x over cosine x times 1 over cosine x, right? So this is just tan x times secant x, or more commonly wrote is just sec x tan x, right? So yeah, that's just secant x. For cosecant x, that's just 1 over sine x, right? So you can do the same thing. So derivative of 1 is 0, minus, you don't need to do the sine 1 times, yeah, you know what I'm saying, right? Minus derivative of sine x is just cosine x, right? Sure. Times 1, don't forget, but like, you can't forget, it doesn't matter. Divided by sine squared x, because that's the bottom one squared, right? So this is just negative cosine x times sine x times 1 over sine x, and this is just negative cotangent x, and this is just cosecant x. Yeah, that's the derivative of cosec x. Don't use the limit definition for these. Like, just do this. Oh, chain rule. That's my favorite one. Because chain rule is like the most utility, you know. Like, let's say you have a function. Let me do some. You have a function like f of x, right? And you raise it. Nah, wait. Okay, no. You have g of f of x, right? If you want to find the derivative of this, you're gonna find the derivative of g times the derivative of f of x. Yeah, that's kind of it. Like, it's hard to explain without examples, right? But like, if fine, I guess we'll explain with example. Like, let's say I have f of x, Nah, fine. We'll explain with examples, like this one, right? This is like f of x, right? It's just x plus 9, and I'm gonna say g of x is just x plus 9 to the 100. I guess, bro, it's hard to explain. You know what? F you, bro. I'm not. Yeah, fine. We're gonna differentiate this, right? So this is just gonna be 100 times x plus 9, subtract 1. That's just gonna be 99. But don't forget, we're gonna multiply by the inside, the derivative of the inside. And the derivative of x plus 9, that's just 1. So that's the actual derivative. But it's not going to always turn out like that. Like, let's say you have sine 6, 7x. I mean, sine to the power of 6, 7x. This is just the same as sine x to the 67, right? So I'm going to differentiate this. I'm going to bring this power down to 67. Subtract 1. That's just going to be sine x to the 66 because you subtracted 1. But I have to multiply by the derivative of the inside, which is just cosine x, right? So the final answer is just 67 sine 66. This is the final answer, right? Let's say you have tan to the power of n of x. If you use the limit definition on this, it might take you like 3 years, about like 10 minutes. But like, you know what I'm saying, right? If you want, you can write this as just tan x to the power of n, and use the power rule. So this is gonna be down, and then multiply by this, and then you're gonna raise tan x to the power of n minus 1 because you subtracted 1, right? But don't forget, times the derivative of tan x. If you don't know the derivative of tan x, it's just secant squared x. But like, if you don't know that, just use the here, right? Just use the quotient rule, I guess. Yeah, you should memorize this, bro. It's not hard for tan x and sin x, and those trigonometry stuff, I guess. Anyways, f of x is equal to x plus, oh fuck, we're gonna use the product rule, right? The differential of this is just 1 times this, so x 2x plus 9 to the power of 9, plus the derivative of this. What is the derivative of 2x plus 9 to the power of 9, right? We're gonna bring down the power by 1. We're gonna bring down the power, so 9 to the 2x plus 9 subtract 1 is gonna be 8 times the derivative of the inside. What's the derivative of 2x plus 9? That's just 2, right? Times 2. So that's just 9 times 2 is just 18. So this is just 18 2x plus 9 to the power of 8 times x plus 1. Don't forget, you have to multiply by this. Yeah. What is sine x times cosine x to the power of n? Fuck. No, actually it's not that bad, right? So we're gonna bring down the power, right? So it's just gonna be n times sine x cosine x to the power of n minus 1. And then you're gonna multiply by the derivative of the inside function. Wait, yeah. I should give a formal one, right? Chain rule is just saying if dy by dx, this is the same as dy by du times du by dx. You can't cancel these. Like, if you have a f, wait, man, I'm not formal. This is like bro science, I guess. Yeah. Anyways, times the derivative of sin x cosine x. What's the derivative of sin x cosine x? Use the product rule, right? Or you could be sigma and write it as half sine 2x and then use the chain rule, but like, oh, nah, never mind. Yeah. Should I? Nah. I'll use the more common one, right? So the derivative of sine x is just cosine x, multiply that by that, so just cosine x plus derivative of cosine x is just negative sine x, then multiply this again. So yeah, so this is just cosine squared x minus sine squared x, which is cosine 2x. But fine, cosine 2x, right? And that's, yeah, and it makes sense, right? Because if you write this as half sine of 2x, right, if you differentiate it, it's gonna be what, half cosine 2x times 2, and these cancel out. So yeah, I'm trying to make sense, but like, you know what I'm saying, bro. It's hard to make sense. Okay, this one seems hard, and that's because it's medium level, but like, you just gotta, it's long, not hard, right? So bring the power down, so 100 subtract 1 times the derivative of the inside. What is the derivative of x plus 9 divided by x plus 10? That's my job to figure out. Hold on. Fine. Use the quotient rule, right? Because this is like two terms, so it's not one term. If it was one term, you could do it faster, but like nah. So we're gonna differentiate the top, so it's gonna be 1, right? Times the bottom minus the bottom, the differential of the bottom, which is 1, right? 1 times the top, x plus 9, divided by the bottom squared, which is x plus 10 whole squared, right? So this is like, I expanded this, I think. This is 1 over x plus 10 whole squared, I guess, times 1 over x plus 10 whole squared. I'm writing this for the question, this one, right? Anyways, sine of 6, 7x. You can think of sine as the function, right? So we're gonna differentiate sine, which is gonna be cosine 6, 7x, right? Times the differential of the inside, which is just 67. So if you write this is gonna be 67 because 6. Holy bro, who's writing these questions, bro? This is rage bait. Okay, wait. There is no space for this, so I'm gonna write the question again. This one, right? You're gonna find the derivative of this. So derivative of cosine x, that's just negative sine, and put the whole function here, right? And then you're gonna times the derivative of the inside. Derivative of the inside is just 3x squared plus 2. So that just, yeah, you're gonna multiply by 3x squared plus 2 and simplify, I guess. But there's, yeah, that's it, I guess. Inverse trig already? It's gonna be a long day, but yeah. Technically you should learn the implicit differentiation before this, but I guess that's my problem to figure out. Yeah, you want to find the inverse, the derivative of inverse trig, right? It's hard to do it by like finding, like normally you can't use the limit definition for this. It's harder to find, right? So we're just gonna say y is equal to tan of negative x, right? And then we're gonna find dy by dx. If y is tan of negative 1x, you can take tan of both sides. So it's just gonna be tan y is equal to tan negative wait, no, my bad. Tan of negative 1 of x, right? So these cancel out. So this is just saying tan of y is equal to x, right? Now we're gonna differentiate both sides. So with respect to x, be careful, right? So if you differentiate this is just secant squared y. But don't forget the chain rule. You gotta multiply by the derivative of the inside. But we don't know the derivative of the inside, right? So I'm gonna just pretend it's just dy by dx, because that's the derivative of y, right? Just derivative of y is just dy by dx. You know what I'm saying, right? And if you differentiate x, that's just 1, right? So now we're gonna get dy by dx is equal to 1 over secant squared y. Okay. Blacked out like a phantom. Yeah, anyways, don't forget we said tan y is equal to x, right? Anyways, you can write secant squared y as just 1 plus tan squared y, right? Because that's an identity, right? Yeah, so you can write this as 1 over 1 plus tan squared y. And we said tan y is x, so tan squared y is just going to be x squared. So that's just going to be 1 over 1 plus x squared. So in the final you get dy by dx is equal to 1 over 1 plus x squared. And we said dy by dx is just the derivative of tan of negative 1x. So you can say in the end tan of negative 1x is just, the derivative of this is just 1 over 1 plus x squared. This is more like common in integrals and stuff, but like you also see it here, right? Same thing with sine and cosine. Fuck, I'm gonna have to do this for everything. No, hi. For sine, I'm gonna just take the sine of both sides. So it's gonna be sine of y is equal to sine of negative 1 of x. These cancel out, so you get sine of y is equal to x. And I'm gonna differentiate both sides. Derivative of sine y is just cosine y. The derivative, and then you gotta multiply by the derivative of the inside. We don't know what's the derivative of y, so I'm gonna just say dy by dx, right? So yeah, is equal to 1 because the derivative of x is 1. And then you just divide by cosine y, so you get dy by by dx is equal to 1 over cosine y. Fine. You see, like, you know the sine squared x plus cosine squared x is equal to 1? You can subtract sine squared and you get what? Cosine squared x is equal to 1 minus sine squared x. And if you take the square root of both sides, you get cosine x is equal to 1 minus sine squared x. So you can write cosine y as just 1, wait, dy by dx. You can write this as 1 over root, wait, no, yeah, root 1 minus sine squared y. But we said y is equal to sine x, right? So you can write it as, so sine squared y is just x squared. So you can write it as 1 over square root of 1 minus x squared. Yeah, I guess. Yeah. Man, I'm tired already. This is fine me. Cosine of negative 1 of x. Do the same thing here. I'm gonna speed on this. So we'll take the cosine of both sides. So it's gonna be cosine negative 1 of x. These cancel out, so you get cosine of y is equal to x. We're gonna differentiate both sides, so it's gonna be negative sine y. Don't forget the negative, times the derivative of y, which is just dy by dx, is equal to 1. If you divide this, wait, why is it not working? Divide this, you get dy by dx. Why is it tripping? Dy by dx is equal to negative, 1 over negative sine y. Man, my iPad is breaking. This shit fine. So you can write it as negative 1 over sine y. And sine y is just square root of 1 minus cosine squared y. So that's just dy by dx is equal to negative 1 square root 1 minus cosine squared y. And we said cosine squared y, we said cosine y is x. So cosine squared y is just x squared. So this is just negative 1 over root 1 minus x squared. Yeah, that's it. Okay, this one's gonna be harder. Y is equal to tan negative 1 of f of x. I'm gonna take tan of both sides, so I get tan y is equal to, these cancel out with the tan, so it's gonna be f of x. I'm gonna differentiate both sides, so you get secant squared y is equal times the derivative of y, which is just dy by dx. Don't forget the chain rule, is equal to f prime of x. And if you divide by secant squared y, you get dy by dx is equal to f prime of x divided by 1 plus secant squared y, my bad. And secant squared y is just 1 plus tan squared y. So again, this is just f prime of x 1 plus tan squared y. And we said tan y is just f of x. So tan squared y is just f of x whole squared, right? F of x whole squared, right? That's it. Yeah, I'm gonna have to do this for a sign. Quick shortcut for this. Don't, I know it's not supposed to memorize, but it's just negative f prime of x divided by square root 1 minus f of x whole squared. I'm too tired to do this, so bro, I'm hibernating. I don't know what that means. Why is my iPad tripping? Hold on. Fine, let me use the blue pen now. Wait. Oh, wait, it's my pen that's broken. Oh. Okay, that's why, I guess. Let me use the blue one. It's serious business. If you want to differentiate this, right, we'll use this formula. So it's negative f prime of x, and this is just f of x, right? So the derivative of f of x is just negative 6x over square root of 1 minus f of x whole squared, which is just 3x squared whole squared. You can think of this as the chain rule as well, because like sine negative 1 of like 6, 7x, right? The derivative of sine negative 1, that's just 1 over square root 1 minus this thing squared. So 6, 7x whole squared. And then you times the derivative of 67x, which is just 6, 7. And that's how you find the derivative. Like, you could do that either ways. You could memorize, or you could just like chain rule, or you could just brute forces, I guess. Implicit. Man, I'm shameless as far as just stealing the questions. Damn. Okay, implicit, right? It's kind of like the chain rule, right? Let's say I have a function like x y plus 6, I'm going to 41x plus 3y is equal to 0, right? And I'm trying to find dy. Oh, what the hell? What the hell? Yeah, I'm trying to find dy by dx, right? So I'll just differentiate all of these terms, right? What is the differential of x? Oh, see, hold on. This is a product, right? So you gotta use the product rule. So what's the differential of x? That's just 1. And then you multiply by y, so it's just gonna be 1 times y, which is just y. Plus, what's the differential of y? We don't know, right? It's the same thing, we don't know. But you can write it as dy by dx, right? Because the differential of y is just dy by dx. Like, look, d by dx, y. Oh. Formal math proof, rigorous, very rigorous, right? And then you're gonna multiply by x. And then you're gonna add the derivative of 41x, which is 41, plus 3. What's the derivative of y? We said that's just dy by dx, okay? And that's still equal to 0. And from this, how do we find dy by dx? Bro, just use common sense and factorize, right? So I'm gonna just send everything that doesn't have dy by dx to the other side, right? So I'm gonna send y and 41 to the other side. So you get dy by dx times x plus this 3 dy by dx is just equal to negative y minus 41, right? Because I sent both of these to the other side. And then I'm gonna take dy by dx common factor, and this is gonna be x plus 3 is equal to negative y over negative 41 divided. There's no dividing, man. Alright, dy by dx is equal to negative y, and then I'm gonna just divide this, right? Minus 41 divided by x plus 3, and that's it, right? Man, should I do all the questions? Man, I'm shameless as well, just stealing these questions. Bye. Yeah, let's do the first one, right? 2x plus 3y, right? So 2x, derivative of 2x is just 2. Wait, let me write the question so it's here. 2x plus 3y is equal to sine x. Okay, derivative of 2x is just 2. Derivative of 3y is 3 times the derivative of y, which is dy by dx, right? And derivative of sine x, that's just cosine x. So I'm gonna just subtract 2. So boom. So I get 3 dy by dx is equal to cosine x minus 2. I'm gonna divide by 3, so I get dy by dx is equal to cosine x minus 2 divided by 3. Boom. Alright, first one. Second one. Fuck. 2x plus 3y is equal to sine y. So the derivative of 2x is just 2. Derivative of 3y is 3 times the derivative of y, which is dy by dx. Derivative of sine y is cosine y, right? But don't forget chain rule, you gotta multiply by the derivative of the inside, so it's gonna be times dy by dx. Yeah. Okay. I'm gonna send this there. So it's gonna be 2 is equal to cosine y dy by dx minus 3 dy by dx. I gotta send all the dy by dx to one side and then factorize it, you know. So 2 is equal to cosine y. Wait, no. I'm gonna factor out dy by dx. So it's gonna be, well, cosine y minus 3. And then I'm gonna divide this there. And I'm gonna just write it as dy by dx is equal to cosine y minus 3 divided by 2. Fuck, I'm wrong. I'm wrong. I'm tripping. 2 divided by cosine y minus 3. Bomba clap. What? Fuck. Should I even do these, bro? My hand is actually dying. You know what? I'm gonna do the 6th question, cause that one seems okay. Okay, more like hunger. What? Okay, yeah. We have x cubed plus x squared y plus xy squared plus y cubed. Oh, I almost thought it's a cubic, but it's not cubic. Wait, yeah, like you could. I thought this was gonna be like x plus y whole cube, but it's not, bro. Cause like, life can't be always this easy. Anyways, differentiate x squared. That's just 3x squared. Differentiate x squared y. We're gonna use the product rule, right? So we're gonna take the derivative of x squared first, which is just 2x times y, plus derivative of y, which is just dy by dx, times x squared. So yeah, just right here, 2xy plus dy by dx x squared. I don't have space. So wait, let me write the whole question again. Can I write the question from memory? Probably is equal to 81, right? I think, hold on, x cubed plus x, yeah, it is. So let's find the derivative. Derivative of x squared is 3x squared plus, we use the chain rule, right? So it's just gonna be 2x times y plus dy by dx times 2x, dy by dx times x squared plus x times y squared, right? This, how to find the derivative, just bring 1 times y squared, which is just y squared, plus the derivative of y squared, which is just 2y dy by dx, because you gotta multiply by the chain rule, you feel me? Yeah, I didn't teach this, but if you have like y squared, right, you're gonna bring the power down, which is 2y, but don't forget this is chain rule as well, so you gotta multiply by dy by dx, I guess. Anyways, oh my god, I'm actually gonna cry. Tears of happiness when I finish this. Where was I? Yeah. Oh, dy by dx, and then don't forget you have to multiply by x again, cause like that's here. So I was just write it as 2xy dy by dx, right? So here, plus y squared, plus 2xy. What? Hi, dy by dx. Y cubed. How to differentiate y cubed? That's just 3y squared. Don't forget the chain rule again. Dy by dx. How to differentiate 81? That's just 0 because it's a constant. And now we factor all the dy by dx. But before that, let me just send every term that doesn't have a dy by dx to the other side. So this, and this. Oh wait, my bad, I got interrupted. But anyways, I'm gonna send this to the other side. So it's gonna be wait, where was I? Yeah, so if you send this to others, let me just write here, right? This is gonna be negative 3x squared, right? This one, and then this one's gonna be negative 2xy. This one's gonna be negative y squared, and I don't think there's any else, right? So I'm gonna just write this down here: dy by dx times x squared plus 2xy dy by dx plus 3y squared dy by dx. Hopefully I didn't forget any terms. Sure. And then I'm gonna take out dy by dx common factor. It's gonna be x squared plus 2xy plus 3y squared is equal to all of that, and then I'm gonna divide that. So in the end, it's gonna be, you know what? I'm too lazy. I'm gonna just copy paste this. Copy, paste, and then I guess, bro. Copy. Wait, no. Copy, paste. Oh, this is why you shouldn't cheat in life. I guess this, and then boom, that's the answer, I think. I'm tired, bro. Let's go to logarithmic. This is my favorite one. Basically, like logarithms, right? Logarithms. Fine. Let's say you have ln, like when I say ln of x, this is just log e of x, right? So I'm just, let's say you want to find the derivative of ln of x. But first of all, I'm gonna set it equal to y, right? And then I'm gonna take e to the y of both sides. So this is gonna be e to the y is equal to e to the ln of x. And e to the ln of x, this is the same as just x, right? Because these cancel out. So this is gonna be e to the y is equal to x. And then I'm gonna differentiate both sides. So it's gonna be the derivative of e to the x is just e to the x. But this is e to the y, so it's gonna be e to the y. But don't forget the chain rule. You gotta multiply by the differential of y, dy by dx, is equal to x. Derivative of x is 1. My bad. Now I'm gonna just divide e to the y on both sides. E to the y. Don't forget we said y is equal to ln of x. So I'm gonna just plug it here. So get dy by dx is equal to 1 over e to the ln of x. these cancel out, so you get dy by dx is equal to 1 over x. And we said y is equal to ln of x, so you get ln, the derivative of ln of x is just 1 over x. Yeah, sheet run. Also, you could do the same thing, right? But for any, let's say you have ln of f of x, this is just going to be f prime of x divided by f of x. And if you want to know like the proof, just use the same method. Instead of y equal to ln of x, just do this, right? And it's going to be the same answer, but I'm just too lazy to figure out. I mean, to do it right now, it's like I have no time, bro. Anyways, now let's say you have log a of f of x, right? I know some textbooks are just going to be like this, and then they're never gonna mention it again, right? This is how you find the logarithm, right? But that's kind of like boring as fuck, and like, come on, bro, memorizing is not cool. This is maths, come on. So let's say, you know the log base, like if you want to change logs, right? I'm gonna just say this is log e of f of x, right? Or like, nah, I want to find the derivative of log a of f of x, okay? How do we find this? Knowing this thing, right? So I'm gonna just, you know the changing base formula. If you have log a of b and you wanted to change it to log c, you just do log c of b divided by a. The way I memorized it, or like, it's not memorized. Yeah, the way I memorized this is b divided by a, so b divided by a. You feel me? I guess. Uh, my methods got wabi sabi, bro. Anyways, so you can write log a of f of x as log e of f of x divided by log e of a, right? And log e of a is a constant because a is a constant, right, in this. So you can write it as 1 over, and sort of log e, let me just write it as ln of a because like it takes less space. Or like, yeah, 1 over this times ln of f of x. And if you want to find the derivative, we know this is a constant, so you can take it outside the derivative. So it's just going to be 1 over ln of a times d by dx of ln of f of x. And we know ln of f of x, that's just f prime of x divided by f of x. And this, what is this handwriting, bro? And if you just do this, this is going to be f prime of x divided by f of x times ln of a. Boom, I guess. Ancient hieroglyphics. Yeah. But the reason we take logarithm, like, yeah, another log rule, like log a of b is just log a plus log b. Log a divided by b is just log a minus b, minus log b, right? This is actually the indices, like this is just a to the m plus n is just a to the m times a to the n. Like if you see this, these are actually the same. This is just like the cooler way of writing this, right? Anyways, I'm not gonna explain it right now. Maybe in different videos, cause like logarithms are kind of cool, bro. Anyways, so these two rules, and you're gonna be set for life, right? The reason we take logarithm differentiation, right, is let's say you have like you have a complicated function like 67x squared plus 9 cube divided by root 1 plus x squared square. Okay, cube, fine. If you do it right now, like common sensely right now, it's gonna be complicated as fuck. Like, so I'm gonna just say y is equal to this, and then ln y is gonna be ln of oh no. You can write it as my bad, I got interrupted. Anyways, you can write it as this, like the thing, right? And using ln properties, you can just split it up as ln of this minus like this minus ln of that, and then you can differentiate both sides. It becomes easier because like you can use the power rule of ln's. Oh yeah, wait, one more. Log a to the x, right? This is the same as x times log a, right? That's it, because you can bring down the power in ln. Yeah, fuck, the first question is hard. No, it's not hard. This is pretty fun. So we're gonna take the natural log of both sides, because like if you have anything to any power that's like a function, like let's say 2 to the sine x, or like 3 to the cosine x, anything to any power of a function, always take natural log, like or like logs. So yeah, so ln of y gonna be ln of x to the x. We can bring down the power, so this is just mean ln of y is equal to x ln of x. And then we're gonna differentiate both sides. The differential of ln of y is just 1 over y, right? But don't forget the power chain rule. So this is gonna be dy by dx, because you gotta multiply by the inside function, right? And then how do you differentiate x ln of x? So we're gonna use the product rule. I'm high as fuck, bro. So we're gonna differentiate this, which is 1 times this, so ln of x, plus differentiate this, which is just 1 over x. So yeah, 1 over x times this, so x. This is just ln of x plus 1, because these cancel out. So yeah, so you're gonna say 1 over y is equal to ln of x plus 1. Then we're gonna multiply both sides by y. So you're gonna get y ln of x plus 1. But don't forget, we said y is equal to x to the x, right? So you're gonna write dy by dx. Why is it slanting like high, bro? Dy by dx is just x to the x times ln of x plus 1. I don't mind the handwriting. Anyways, a to the x, same thing. Obviously, y'all memorize this because like y'all are fobs. This is the answer, right? Real sigmas derive this even if they know the method, right? Because like, I don't know. So we're gonna take natural log of both sides, so get ln of y is just ln of a to the x, bring down the power, so it's gonna be x times ln of a, because you brought it down, you feel me? Differentiate both sides, so it's gonna be 1 over y times this, derivative of this, dy by dx, is equal to x. Oh, what's the derivative of x ln a? Don't forget, ln a, or like log e of a, is just a constant, right? So you of a, right? It's just a constant, so you can bring it out, right? So it's gonna be what? ln of a, because the derivative of x ln a is just ln of a, right? So you get dy by dx is equal to y times ln of a, which is just a to the x times ln of a. So that's the answer, right? Like we said before, I guess. Bro, it's like 3 a.m, bro. It's not, it's like 5 p.m. I don't know what's the time, bro. I haven't went outside. Anyways, we do the same thing here, right? ln of y is equal to ln of 2 sine x. Bring down the power, so it's going to be sine x ln of 2. Differentiate both sides to get 1 over y ln. Wait, speed running this is wrong, bro. dy by dx is equal to, what is this equal to? This is cosine x times ln of 2, because ln of 2 is a constant, right? 0.693, right? That's ln of 2, I think. I don't know why I know this. Anyways, so you get dy by dx. It's just y times cosine x of ln of 2. And we said y is equal to 2 sine x. So you get dy by dx is equal to 2 sine x times cosine x plus, ln y, times ln of 2. I guess, bro, I guess. Y is equal to log x of log x. I'm gonna assume this is just log e. So here. So yeah, y is equal to ln of x to the power of ln of x. But this is not, wait, can you bring the power in front? No. The only time you can bring a power in front if it's x to the n, or like x to the log x, right? But if it's the whole function, you can't bring it to the front, because that's not how it works, right? So yeah, we're gonna take the natural log of both sides to get ln of y is equal to ln of x to the power of ln of x, and then you can bring down the ln of x, so this becomes ln of x times that. That's multiply, not functional. ln of x times ln of x, right? Fuck, I forgot. Wait. Let's restart, because like there's not enough space, bro. It's respeeding. Ln, wait, y is equal to log x, right? So you're gonna get ln of y is equal to log x times ln wait, what's happening? Okay, wait, ln of log x to the power of log x, right? And then ln y is equal to log x times ln of log x. So get 1 over y times dy by dx is equal to, you're gonna, wait, what's this? Log x? Yeah, it's log x. Okay, fine. You're gonna differentiate this as a product rule, right? So differentiate this is just 1 over x times all of that ln of log of x plus the differential of ln of log of x. Okay, how do you find this, right? First of all, the reason I'm not writing this as ln of x because that's confusing as fuck. Anyways, first of all, you're gonna differentiate this, right? So you're gonna write it as, or like whenever you have ln of a function, right, of like 6 7x. Oh my god, this is the 80th time. X squared plus 1. The way I think of this is like, I think of it as a fraction. I put this down here, then I differentiate this off. So you could put it down here, which is log x, and then you differentiate log x, which is just 1 over x. You can simplify this, and it just becomes 1 over x log x, right? Because yeah. So plus 1 over x log x, and then don't forget you gotta multiply this by log x. So this cancels out, so you get 1 over 1 over y dy by dx is equal to 1 over x, and let me just take on 1 over x common factor from these two, right? From these two, take on 1 over x common factor and plus 1. So you get dy by dx is equal to y times all of that, and we said y is just log x to the log x, so this is just going to be log x times to the log x of 1 over x. You know what, instead of ln, let me just write it as log x because it looks cooler. Log x of log x plus 1. Yeah, I think that's the answer. Anyways, log a of x, we know the answer, right? It's just f prime of x divided by f of x times ln of a, or for this, f prime of x is just 1, because like the derivative of x is 1, f of x is just x, ln of a is just ln of a, so that's the answer. Okay, this is a trick question, right? How do you find a derivative of this? The answer is you don't take ln of both sides, because that's useless, right? We know the power rule, or like not the power rule. Yeah, it is power rule of logarithms. You just bring down the power, so you get y is equal to x log 3. Log 3 is a constant, so this is just dy by dx. It's just log 3. Yeah. Yeah, I guess. Fuck, parametric. Okay, this is the 80th time, bro. I'm gonna find parametric. You know what? Let's go back to the black pen. Parametric, right? Let's say you have a function of like x is equal to 4 sine t, and y is equal to 5 sine, no, cosine t, right? If you want a different, nah, you know what, let me start with something basic. You have x is equal to x squared, no, x is equal to t squared, y is equal to t squared minus 5t plus 6. Find dy by dx, right? Now you could do one method, and that is just sub in t in here. Like you could write elimination. It's kind of like an elimination, right? So this is y is equal to t squared, like that. So you can write y is equal to, this is t squared is just x minus 5, and then t is just root of x plus 6. Then you find dy by dx by power rule and stuff like that. Or you can find dx by dt, right? And then you divide this by dy. No, wait. Whoops. We're trying to find dy by dx. dy over dt, and then you divide this by dx over dt, and if you do this, these cancel out, so you get dy over dx. Wait, my mom came, hold on. Alright, anyways, you can write it as dy over dt divided by dx by dt, and these cancel out. I know you can't treat dy over dt as a fraction, right? It's not actually a fraction, but I'm a sigma. I break the rules, so I'm gonna treat it as a fraction. Then you can divide by this, and this is just dy by dx, right? This is like the chain rule, right? Dy by dx is equal to dy by du times du by dx. That's like, you can't cancel out, but technically you can, but technically you can't. Like, you know. Anyways, so yeah, let's find the dy by dt, right? So we're gonna differentiate y with respect to t. So this is just gonna be t squared, 2t minus 5, right? And dx by dt is just gonna be 2t. So we're gonna divide this, so dy by dt divided by dx by dt. So this is just gonna be 2t minus 5, right? Divided by 2t, and that's your answer. Or you can simplify this and you can write it as 2t divided by 2t minus 5 divided by 2t. This is just 1 minus 5 over 2t. I'm tired already, bro. Damn, I'm shameless as well. I didn't even make these questions. Anyways, let's find dx by dt. First of all, let's find dx by dt. So dx by dt is just power rule, right? 4 times a times t. So that's just 4at. And let's find dy by dt. So that's just gonna be 4at cubed. Yeah. Then you divide this by this, so it's gonna be dy by dt divided by dx by dt, which is just this is equal to dy by dx. This is not true, but like, you know what I'm saying. So this is just 4at cubed divided by 4at, and these cancel out, and one of the t cancel out, so you get dy by dx is equal to t squared. Boom. That felt nice, I guess. Third question. Okay. X is equal to sine t. Y is equal to cosine 2t. Fuck. Yeah, fine. Let's find dx by dt. So this is just gonna be cosine t, right? Sure. You know you're fine when you're doing this. Dy by dx is equal to, so we're gonna use the chain rule, right? So first of all, we're gonna differentiate cosine of 2t, which is just negative sine 2t, and then we're gonna multiply by the inside, which is just 2. So you're gonna get negative 2, times 2. So in the final, you're gonna get negative 2 sine 2t. Then you divide this. Wait, this is not even dy by dx. This is dy by dt. My bad. You divide this by this, and this is what's happening, bro? So you get the final answer is this divided by this, which is just negative sine 2t divided by cosine t. You can actually simplify this, I think, right? Because this is just negative, and sine of 2x is just 2 sine x cos x, right? So hold on. So we can write it as negative 2 times 2 sine t cosine t over cosine t, and these cancel out, so it gets negative, and this is 2 times 2 is 4 sine t. Fuck. Okay, final one. Fine. Wait, is this the final? Oh no. Wait, I didn't even have. Oh, what's happening? I'm glitching. X is equal to cosine theta minus cosine 2 theta, right? Okay, fine. And we have y is equal to sine theta minus sine 2 theta. Okay, let's find dx by d theta. Because look, the final goal is just to do dy by z theta divided by dx by z theta. So these cancel out, so you get dy by dx, right? So let's find dy by d theta first. So the derivative of sine theta is just cosine theta. Derivative of sine 2 theta is, you're gonna use the chain rule, right? It's just gonna be, fuck, it's just gonna be 2 cosine 2 theta. You can do this later, bro. I'm fried, actually. Right? Is it? Probably. And then dx by z theta, that's just so differentiating cos theta is just negative sine theta. Differentiating cosine 2 theta is just plus 2 sine 2 theta, right? be smaller? Probably, yeah. And then you divide this by this, so you're gonna get cos dy by dx is equal to cos theta minus sine. Wait, no. Wait, yeah. Wait, I guess, bro. Uh, I'm just copying this down. I'm gonna divide this by this, and you can simplify this, but that's for another day. There is one more method. I don't know why there is some miscellaneous questions, right? But there is one more, which is partial derivatives. Fuck. Okay, anyways, let's say you have a function, right? X squared plus y, no, yeah, for x squared y plus 3xy plus 7xy, plus 7x squared y is equal to 0. So partial derivatives is like if you give implicit differentiation, but you're blind, okay? You're just blind to a whole constant, right? So let's say I want to find d. It's not d. It's like this. It's like that. You feel me? Divided by dx, right? Partial derivative of x. Now I'm gonna just pretend that y is a constant, right? So we're gonna differentiate this, right? X squared y. Normally you'd use the product rule, but we're gonna pretend y is a constant. So this is just gonna be 2x times y because it's a constant, right? Plus differentiate 3xy. We're gonna pretend y is a constant, so x goes is like 3y, right? Plus 7x squared y is just 14x. Y is a constant, so just y, and that's it. That's the partial derivative of x. There's also partial, like, yeah, there's, I'm not gonna do any questions on this because, like, yeah, I'm homeless. There's also one more, which is it's like a cool trick, right? If you have an implicit function, let's say jobs, bro, jobs. If you have an implicit one, fuck, I don't want to do a long one. This one. And if you want to find a short trick, if you want to find this in like 5 seconds, not 5, like in a minute, right? You can do the negative partial derivative of x divided by partial derivative of y, and that's just going to be the implicit differentiation, right? There is a proof for this. It's not even rigorous, but like, yeah. So let me just let me do this, right? X squared plus xy plus y. Okay, hold on, bro. X squared. Wait. X squared plus, oh fuck, I forgot already. I think it's xy plus y squared is equal to 100, right? I think, is it? It's been yeah, fine. So, but there's one condition, is that it should be all in one side, so I'll just subtract 100 so it becomes 0. And then we can use the trick, right? Negative partial derivative of x divided by partial derivative of y, right? And that's just going to be dy by dx. So what's the partial derivative of x? So it's just going to be, we're going to pretend y is a constant, so this is just 2x plus y is a constant, so this is going to be y, plus the y is a constant, so it's just going to remove it, and this is also a constant, so remove it. So that's just d by dx, right? But we don't want dy by dx, we want negative d by dx, and then divided by partial derivative of y. This is a constant in the y world. Yx is just x, because yeah, and y squared is just plus 2y, and 100 is a constant. So yeah, this is the answer. If you want, this is dy by dx. It's a cool trick. It's a faster way, I guess. Final one. This is a little bit of this and a little bit of that. You know what? All of these are kind of mid. You know what? I'm gonna do this. I don't want to do and this maybe, because this seems hard, and maybe this. The other ones is your job to figure out. Although they aren't hard, but let me do this first. This one is actually a good question. I remember this. I think. This is just this, right? X. Wait, hold on. I'm writing the question. X plus 6, x plus 7. Okay. X plus 6, x plus 7 times x 9 plus 10, right? If you want to find the derivative of this, well, first of all, whenever in derivatives, right? Whenever you have a radical like x cubed, x to the 4, just write it as x to the power 1 over 4, right? Especially if it's logarithms, right? So I'm gonna just write it as ln of this. Hold on. to the power of 1 over 8, because that's just this cube, and that's the 8 roots, right? Just power 1 over 8. And then by the properties, you can bring this down. So this is just 1 over 8 times ln of x plus 6, x plus 7, x plus 9, okay? I'm gonna just take on 1 over 8 common factor, right? You can write, by the properties log a, b, right? You can write it as log a plus log b. Yeah, so you can write this as log, or like ln of x plus 6, right? X plus 6 plus log x plus 7. Wait, ln, my bad. Ln x plus 7 plus ln x squared. I'm dead, bro. Then you differentiate this, right? So this is good practice, I guess. Whenever you're doing ln, think of it as a fraction, right? Put this one down here, so x plus 6, and then differentiate this, so it's just 1 plus, put this fraction, put this one down here, so x plus 7, differentiate this, so it's just 1 plus, put this down here, so x squared, x to the 9 plus 10, differentiate it, which is just 9x to the 8, because yeah, power rule, and that's the derivative. And then you sub in whatever they want, 3, so you sub in 3 and then put it on the calculator, and that's it, I guess. Fuck, wait, this one, hold on, can I copy paste this? Copy, wait, no, paste. Ooh, technologia. If you know, you know. Well, anyways, where do I even start? Fuck, is this hard one? Probably. Okay, look. Oh wait, I found it. Okay, I found a trick, right? It's the top, right? It's just e to the x squared minus 1 plus e to the x 1 minus x squared, right? I'm gonna take a negative from this, so I'm gonna have to take a negative outside as well, right? Because to keep the balance. So this is just the same as e to the x squared minus 1 minus e to the x, and what's minus 1 over 1 minus, I'm drunk, bro. This is just x squared minus 1, right? So you can put in x squared minus 1 and divided by x cubed plus 3, plus 1, but it doesn't matter because these actually just cancel out each other, right? So this is just f of x is equal to root, because like all of this is 0, so this is just 1 plus sine x squared, so you just f of x is just this, right? Root e to the x plus 1. I told you in derivatives, you don't want to write this as root, you just write it as to the power of half. So I'll just write f of x is equal to 1 plus wait, why is it wabi sabi? Hold on. F of x is equal to 1 plus sine x squared to the power of half, and root is just the same as, you can multiply this, is just 2, so it's just e to the x plus 1 whole to the half, so it's just 1 over 4, right? If you multiply, like, yeah, I guess, bro, divided by 1, e to the x plus 1 to the power of 1 over 4. Wait, this is 2. And then instead of doing this like the quotient rule, let's do logarithms, right? So I'm gonna name this y. So ln of y is just ln of I'm not writing all of this. Boom. Yeah, wait, no, wait, let me take a copy paste, because like you're gonna need y in the end, because like, yeah, how does take a copy? What the hell? Copy paste. Oh shit, hi. Man, this is gonna be a long day editing this. I'm not editing shit, low-key, bye. So by properties, you can write it as ln, like, you know, ln of a over b is just ln, or like log a over b is just log a minus log b, right? So you can write it as ln y is equal to, so I'm gonna just write this as a and this as b, so it's just gonna be ln of this, the top one, to the power of half, minus the bottom one, so to the power of 1 over 4. Yeah, and then by the properties, you can bring the power of half down, so it's going to be half ln 1 plus sine x squared minus ln, bring the power 1 over 4, so 1 over 4 ln e to the x plus 1. And then you differentiate both sides, right? So you get 1 over y times the chain rule dy by dx is equal to, and then you're going to differentiate this side, so it's going to be half, and then don't forget you just write this in the bottom, so write this in the bottom, and then the derivative of this inside here, so it's just going to be what, so derivative of 1 plus sine x squared, we're going to use the chain rule. Oh man, hi. So it's gonna be, it's just gonna be cosine x squared, right? And then you're gonna times the derivative of the inside, which is 2x. So in the end, it's gonna be 2x cosine x squared, and 2 and 2 cancels. And then you subtract 1 over 4 times the derivative. You just put this in the bottom, so 1 e to the x plus 1 times, this is times, okay, this is like, yeah, I'm drunk, bro, times the derivative of e to the x plus 1. The derivative of e to the x is just e to the x, so e to the x here. Anyways, the derivative of e to the x plus 1 is just e to the x, so you get dy by dx is just multiplied by y, and that's just x cos x squared divided by 1 plus sine x squared minus, distribute the 1 over 4, so it's going to be e to the x 4 e to the x plus 1, and then put in y, all of this in here, and then you could simplify and then put the number, which is what, where is it, this one, you put 3 inside, and that's it. You know what, I give up, I'm not doing this final question. Oh fine, fuck it, just the final one I'm gonna do. Fuck, is it what, sec cos sine, fine, sec cos sine x, find dy by dx. Well, I'm gonna say u, wait, I'm gonna say u as cos sine x, right? And so we know this is just secant u, right? All of this. So don't forget the chain rule, dy by dx is equal to dy by du times du by dx. Dy by du is just, wait, what's the derivative of secant u? Secant u tan u times du by dx, which is like the derivative of this. The fuck. Yeah, you're gonna, like, okay, fine. Derivative of cosine x, that's just sine of x. But you also gotta multiply by the derivative of the inside, which is just cosine x. So yeah, that's the final secant, this is u, okay, times sine of x times cosine of x, and we know u is just this, so you're gonna sub this back in, so you get secant of cos of sine x times tan, times tan of cos of sine x times sine of sine x times cos x. Okay, that's the final answer. You could, I don't think you can even simplify this. Maybe you could, but it doesn't matter, right? That's the final one. Bro, it's a long day. Yeah, maybe next time I should split it up. You know, not 3-hour video, I guess.